For an extremely extensive stretch, people have conjectured about what presence may resemble on different universes. On account of the James Webb Space Telescope, the most exceptional telescope in existence, this question can at last be addressed. While examining the closest star system to us, Proxima Centauri, which is simply 4 light-years away, researchers have noticed a few uncommon peculiarities from one of the planets in the system, Proxima B. These irregularities, alluded to as artificial lights, have confused the most brilliant minds in mainstream science. Yet what are they? Do these lights infer the presence of intelligent life on the planet? Join us as we dig into the James Webb's surprising revelation of city lights that change everything. The only life that we currently perceive is on Earth. Since the beginning of civilization, people have questioned whether there is life elsewhere in the universe. To embrace such an interstellar pursuit, Americanologists Jill Tarter and Thomas Pearson started the search for extraterrestrial intelligence, SETI project in 1984. The charity's objective is to gather spaceborne radio transmissions. Radio waves can travel further and are consequently more likely to be detected by the 42 radio telescopes that comprise the unique Allen Telescope Array in the California Sierra Mountains, as they are less scattered or absorbed than other kinds of radiation. However, in the past 30 years, no obvious extraterrestrial transmission has been found. Hence, the James Webb Space Telescope's successful launch aided the quest to explore a range of distances and unseen planets circling distant stars. The largest telescope on the planet, which is drifting roughly 1 million miles from Earth and outfitted with incredibly delicate detectors, will be used. A while back, there were no known planets beyond those in our solar system. Yet since then, over 4,000 exoplanets have been found circling different stars. According to NASA, the universe could contain trillions of exoplanets. The earliest signs of life beyond our solar system may be found in extraterrestrial vegetation. The Galileo spacecraft turned its instruments back toward Earth while en route to Jupiter and found an obvious indicator of the presence of plants. The instrument detected the vegetation red edge, a mix of red and infrared lights reflected by plants. For instance, a planet like Earth shrouded in a jungle should have a strong and easily discernible red edge. The JWST will measure the red edge of distant Earth-like planets in the habitable zone around stars. These could be significant markers of life in the exoplanet atmosphere. When sunlight passes through a planet's atmosphere, the JWST could detect it as it enters its atmosphere. The light's missing frequencies would then be identified through spectroscopy. Ions and atoms in the atmosphere absorb specific frequencies, creating a distinct fingerprint that the JWST can perceive. This process might be used to learn the composition of the atmosphere and if life is plausible. Most likely, life could exist on Earth-sized planets with an atmosphere similar to ours, with a prevalence of oxygen, nitrogen, and carbon dioxide. By looking for components that are not regularly present, one might detect technological life. Chlorofluorocarbons, CFCs, produced for refrigeration and cleaning products, would likely be detectable to extraterrestrials observing Earth's atmosphere from afar. If the JWST identified CFCs in planetary atmospheres, that would be a clear indicator of civilization. In fact, life on exoplanets might not resemble life on Earth. Sometimes even natural life, like extremophile species, can seem alien. This is a group of organisms, primarily microbes, that can survive in conditions where other living things would die. Some can endure temperatures up to 250 degrees Fahrenheit, some can survive cold as low as -4 degrees Fahrenheit, and some can survive in highly acidic environments with pH levels below 3. Others can be found on Earth where we wouldn't expect to find any life at all. However, since planets like Earth are more likely to support life than planets with extreme temperatures or acidic conditions, it may be wise to start with those first. Prime candidates could have temperatures that allow liquid water to exist on their surfaces and orbit a stable star. The classification for our Sun is a yellow G-type star. These stars are rarer and usually have shorter lifespans in our universe. The likelihood of studying planets orbiting red dwarf stars, which are more common and have lower luminosities and temperatures than the Sun, is higher. There is more opportunity for the development of life and evolution to create complex life forms because these stars have longer lifespans. Located approximately 40 light-years from Earth, The TRAPPIST-1 planetary system will be the focus of JWST's first mission. It orbits a cool red dwarf star with 7 Earth-sized rocky planets. 3 of the rocky planets in the so-called habitable zone could have liquid water on their surfaces. The TRAPPIST-1 star, despite having a much smaller and cooler mass than our Sun, emits light similar to that of Earth. Due to the close orbit of its planets, the most plausible opportunity for us to see city lights outside the solar system is Proxima Centauri, a red dwarf star that is 4.25 light-years from the Sun. Our closest star, Proxima, is multiple times fainter than the Sun, so a planet would need to be much closer to it than Earth is to the Sun for it to support life based on liquid water. In August 2016, astronomers found a planet with 1.3 times the mass in the habitable zone, or Goldilocks zone, where the light intensity is just right to allow water to remain liquid. Proxima B orbits Proxima Centauri. If it is possible, Proxima B might be an airless dead planet, given that it orbits its red dwarf star, Proxima Centauri, at a distance of only 4.6 million miles. The planet Proxima B is in a close orbit that exposes it to strong solar winds that could strip away its atmosphere. It also receives enough sunlight for temperatures and liquid water that are nearly identical to those on Earth. Due to its proximity to the star, Proxima B is believed to be tidally locked, always showing the same side to the star. Similar to Earth, Proxima Centauri is about 18% the mass of the Sun and shines much less brightly than one might expect for a planet so close to its star, only 5% of the Sun's brightness. This may be expected to be a superhot ash, though liquid water could exist on Proxima B as long as the planet has an atmosphere to retain heat, since the total energy reaching it from the star is only 65% of what Earth receives. Currently, the planet is not particularly inviting to life. It is probably tidally locked, meaning it always faces the same direction towards the star, causing significant temperature variations. The planet also receives 100 times more high-energy radiation than Earth does due to its proximity to Proxima Centauri, including X-rays and ultraviolet light. Proxima B is also bombarded with high-energy particles during star flare-ups. Unless it has a protective magnetic field like Earth, however, there are some plausible conditions that could make it a habitable world. Models suggest that the atmosphere of tidally locked planets might be prone to rapid breakdown due to the freezing out of volatile gases on the night side. A planet's atmosphere can be replenished by volcanic activity, and for planets with strong magnetic fields, this atmosphere is less likely to escape. Since we know nothing about Proxima B's volcanic activity or magnetic field strength, we can't even estimate whether the planet has an atmosphere. However, since an atmosphere implies the presence of CFCs, and the two combined suggest the presence of life, we are eager to find out if Proxima B has an advanced civilization. It could have solar panels covering the day side to generate power to light and warm the night side, which would otherwise be too cold and dark for comfortable habitation. The discovery of Proxima B has sparked a race to determine whether it transits its star as seen from Earth. These transits would allow researchers to determine the planet's size and mass, which would then enable them to learn its density. Knowing this would confirm the planet's rocky composition and provide information on the materials used to form those rocks. During a transit, starlight could reveal the nature of the planet by passing through its atmosphere. However, the probability that the orbit will be aligned for researchers to observe a transit is only 1.5%. The star's tendency to flare also complicates matters. Astronomer David Kipping of Columbia University says the star is unstable, as a star's heat makes a rocky planet absorb sunlight and re-emit it as infrared light. Rocky planets produce a unique type of infrared radiation from stars like Proxima Centauri. Moreover, the James Webb Space Telescope was specifically designed to study infrared light. Proxima B's infrared heat signature is crucial for identifying the planet's atmosphere. Furthermore, the infrared part of the spectrum has strong signals for water. The JWST will be able to detect artificial illumination on Proxima B's night side, even if it were as faint as what our civilization currently uses on the night side of Earth. JWST could detect artificial lighting as long as it was confined to a frequency band that is multiple times narrower than starlight. Proxima B's day side is heavily covered with solar panels. Due to its unique spectral edge capacity to reflect starlight as Proxima B orbits its star day in and day out, its day and night temperatures would be crucial for determining how much heat is still retained. JWST will monitor Proxima B's night side. Despite the planet being extremely cold, JWST's infrared vision will help find artificial light. When light from the night side passes through the atmosphere, researchers will use JWST to analyze it. Exploring the potential for extraterrestrial life has captivated scientists and enthusiasts alike for decades. The advancement of technology has enabled unprecedented observations, offering new insights into distant worlds. With the capabilities of the James Webb Space Telescope, we may soon uncover extraordinary evidence of intelligent life beyond our solar system. Join us on this cosmic journey as we unravel the mysteries of Proxima B and search for signs of city lights that could redefine our understanding of life in the universe.